1 here. So we have, I'll read it with you. The commercial for this. So I hope you have this open. This is lecture 9.2, question 1. So the commercial for the new Meat Man barbecue claims that it takes 15 minutes for assembly. That's a claim. Notice the claim. See that word right there? That's important. That's really the starting point. A consumer advocate, it's like one of those groups that, you know, tries to make sure companies are being honest about what they say in their commercials and stuff, thinks that the assembly time is different. He thinks, nah, they're making it up. They're not being honest in their commercial. They're just pretending that you can set up that Meat Man barbecue quickly and easily. And in reality, the thing's a big pain. The advocate surveyed, so what this advocate did is they grabbed 12 randomly selected people who bought the Meat Man barbecue and found that their average time was 17.4 minutes, right? Not 15 minutes. Y'all see that? It's not 15. They said it's 15, and they surveyed 12 people. The consumer advocate group surveyed 12 people and found their average time was 17.4. So that's not coming out 15. But it's also not really far from 15. So maybe there's a chance that it really is 15 and these people are just a little bit slower than your average people, these 12 people. The standard deviation was 3.2. That means there's also some deviation. Not everybody was exactly the same. Some were higher, some were lower. The average amount of that they were off the middle, that's called standard deviation, is 3.2. What can be concluded at the alpha 0.05 significance level? I repeated the words. I didn't write this, actually. They did. So anyway, they're repeating the words twice. I should fix that question. Whatever. Alpha 0.05. So that's how close you're testing it. The lower the alpha level, the more serious the test. Okay, so here we go. For this study, we should use, well, let's go to the notes now. Let's go to the notes. We'll let the notes guide us. Let the notes kind of help us. So let me do that. Let me add a page here. And I'll pop it in here. There we go. So I'm grabbing for you here the notes. In fact, let me put in a second page of notes as well. There we go. And one more. Let me put in these 3 and we'll be ready. So I'm going to the notes, the exam 3 notes. Let me write that right here. So exam 3 notes. So you all have this available. I updated it and it's in the modules, very top of module 3. I also sent it out as an email to y'all. Okay, what does it say to do? What's the first step? Write the claim from the words, right? That's either going to be equals or not equal or greater or less. Or it could be you equal, not equal, greater or less. How do we know whether it's P? P stands for proportion or percentage, basically the same thing. U, that stands for mean or average. So U is mean, or it's the Greek letter thing, whatever. It's mean or average. And P stands for proportion or percentage. So which one do we have on this problem? Let's go back to the question. Are we talking about percentages? Do you guys see any percentages anywhere?
I see that it says their average time.
Yeah, exactly. Good job. So this is the U kind, isn't it? Yeah, right on. That's U. I'm making the Greek one, whatever. We'll just use a plain U. Yeah, it's the U. It's really the symbol that looks like that, but whatever. Who cares? It's just a Greek M, but whatever. I'm not going to bore you with those details. I just make it like a U. Good enough. Yeah, and then that's what we use for average or mean. It's technically what's called a mu. I keep saying I don't care, and then I keep telling you. I guess I don't care, but you might see this if you ever use statistics anywhere else. So I want you to understand for your own purposes. I'm not going to test you on it or care that much, but it really is a Greek M is what it is, called mu, and it's for the first letter M in the word mean. That's what it is. But anyway, I'll just call it U, and it stands for average, mean. And so, yeah, because we see the word average, we know that this is an average problem, not a P problem. Does that make sense? That's what's new in this section. This whole section is going to be average problems. 9.2 is average. They're all average problems. 9.1 was P problems. They were percentages. In other words, they would say, 50% of the people, prefer this candidate, or 70% of the people like the Meat Man barbecue, right? They were all percentage questions. Today, 9.2, they're all average questions. What's the average time to set up the barbecue? What's the average score on that test? What's the, it's all going to be averages today. That's the difference between 9.1 and 9.2. Those are the two kinds of questions you'll have on exam 3. You'll have P questions, percentage, and that goes for confidence intervals and hypothesis tests, chapter 8 and chapter 9. You're going to need to identify, is it a P question, a percentage, or is it an average question, a U question? All right, yeah, good job. It's an average question. There's no percentages anywhere in this question. It's a U average. So we come on down here. What are we supposed to do then? We're supposed to write the claim from the words, and we're going to write it with a U. It's either going to be U equals, doesn't equal, greater, or less. How do we know which one it is? Well, let's see. Let's go back to the claim. Get rid of this. What is the claim? I'll leave this. This is a good job. What is the claim? It says right here, claims that it takes 15 minutes. The claim then is that now it's equals 15. Does that make sense? See, if they said it's greater than 15, then I would have put greater. If they said it's less than 15, then I would have put less. If they would have said it's different than 15, then I would have put not equals. Remember those different words? All they said is that it takes 15. So that means it is 15. It equals 15, right? So that's what's being claimed. That's your first step. They're claiming, the commercial for the Meat Man barbecue claims that their barbecue only takes 15 minutes to assemble, to set up. So the claim is mu equals 15. Start there. All right, that's step number 1. Write the claim from the words. And then step number 2, write HO, and HO is always, note, HO is always equal. Everybody see that? I tried to make these instructions more clear for you. HO is always equal. So go ahead and write HO and write equals. Even though I'll come back to part A. Let me hold off on part A. I'll come back to it. I'm going to write HO, and this is going to be mu equals, and equals what number? Well, 15, right? That's our number. This makes sense so far? HO is always equals. Always equals. Actually, we can answer part A now too. Let's go ahead and answer part A. The answer to part A, if you notice the notes I gave you, the exam 3 notes, number 3 tells you all the setup stuff. Way down on number 4 is how you do the calculator stuff. And we're down here on mean, aren't we? So I'm jumping to, this is exam 3 notes still. And this is number 4. And it says if you're doing P or percentage, that's what we did back on 9.1. Now we're in 9.2 today. We're doing mean. And it says, okay, you're going to use the t-test. See how they're both t-test? Either part is t-test. So when you're doing mean, you're using t-test. When we did the P or percentage last time, we did the 1 prop z-test. See that? That was 9.1. In 9.2, we're going to do a t-test. So we know the answer to part A up there is t-test. So let's go back up. Part A, you're gonna select t-test. All right, let's come on down. Now, what are we going to do for H1? Well, it's U again. Now, I know a lot of people get confused right here. Y'all with me? I know you're probably kind of working on your own and stuff, but hear this. This will really help you. If you do the setup right on a hypothesis test, the rest will flow. It really will. You just have to be careful on the setup, get that right, and everything else will kind of naturally flow for you. So especially the H1, we got to get that right. How do we know what H1 is? So everybody's seeing, first off, what I'm saying. HO is always, let me write the word always there for you. Always equals, right? HO is always equals. And so we wrote that. HO is equals, always. Now, how do we know what H1 is? Well, I wrote some more instructions to try to help make that more clear for you. Going down here. And so here's the exam 3 notes. Oops, I just erased it. Write that again. So here's the exam 3 notes. And here was my effort to make this more clear. Either, notice these instructions, these are new. Either HO or H1 must be the same as the claim from part A above. That's huge. Let that sink in for a second. One of those two is going to be the claim. Every time, no exception. Either HO or H1. Sometimes it's HO, sometimes it's H1. But for sure, one of those two has to be identical to the claim. Are y'all hearing me on that? That's really important, and that'll really help you know what to do. So let that sink in. One of those two is always the claim, right? Something's being claimed. That's what a hypothesis test is all about. Something is being claimed. It's like two lawyers in a trial. Got the prosecutor and the defense attorney, right? One of them is going to take the claim, and the other one will argue against it. So that's why we did the claim first. That's why that's so important to do that first. So one of those two is the claim. Which one? Is it HO or is it H1? Well, here's how you know. Option number one, there's only two options. Option number one, if the claim is equals, and ours was, Remember our claim? Let me go back up real quick. There it is, equals, right? Our claim is equals. It is 15. So if the claim is equals, that's us, then write claim next to HO, and H1 will be not equals, because H1 has to be the opposite. HO and H1 are opposite, right? So there's our instructions. If the claim is equals, then the claim is HO, because HO is what? Always equals. Make sense? And H1 is going to be what? The opposite of equals, not equals. Let's go do that. So this is going to be, so I'm going to write claim right up here by HO, and I'm going to write not equals 15 by H1. That's what it told me to do. Did you all see that? And you see how the claim exactly matches HO, doesn't it? What is being claimed is HO on this problem. Sometimes what is being claimed is H1. All right. Let's go forward from there. Next question, part C. Find, now we start using our calculator. They want the test statistic, the p-value, and all that stuff. So now it should flow. We're going to use our calculator. So how are we going to use our calculator? Let me make note of the key facts. We have standard deviation. So I'm going to write SD, standard deviation, 3.2. N is 12 right here, 12 randomly selected people. So N is always the number of people in your study. And the average, right there, the average time was, so the average X bar average was 17.4. I know that might be confusing. You might say, wait a minute, Mr. Wait. You're saying the average, you're saying right here the average is U and the average is 15, but now you're saying the average is 17.4. What's going on? Well, right. There's a claim. Somebody's claiming they think the true average for the barbecue is 15. Like for all people that would ever set up the barbecue, the true average is 15 minutes. That's what they're claiming. But we did a little study with Twitter, the advocate group did a little study with 12 people, and the average for those 12 people was 17.4. So you get it? We're comparing the average for the group. I'm hearing a lot of noise. Are we all muted okay? I want to make sure everybody can hear me okay. Here we go. All right. So so is everybody seeing that then? There's an average for the group, and we're comparing that to the average being claimed. All right, so let's go on down and use our calculator. We come on down now to the part 4, which has the calculator stuff. And under mean, that's where we're at for 9.2, it's mean. No data given, that's where there's no data given. There's not list of data. You'll see the data problems in a little bit. No data given. You're going to choose t-test and choose stats, put in U0, X bar, S sub X, in, and the information. All right, there it all is. I'm going to go write it out as we go right here. So in fact, maybe I'll add a page, put in that I think I'll put in that information. In fact, probably be best if I just put it right here for you. Let me do that. I'll just squeeze it in right here, I think. So I'm going to hit stat and go over to tests. Go down and remember what we're choosing? T-test. And then hit enter. So we're choosing t-test. Let me try that again. T-test and hit enter. So that's what it told us to use, the t-test. Hit enter. And then choose stats. It'll have data and stats. Choose stats and hit enter. And then it'll ask you for some stuff. It'll ask you for mu sub 0, X bar, S sub X, in. And so we put these in. And so mu 0, that always comes from H0. So that little 0 should remind you of the H sub 0. You see that? Let that little 0 remind you in the weeks to come, we're going to have more and more complex hypothesis tests, but we'll keep having that little 0 thing. And so that'll remind you, go grab whatever's next to the H0. Let that remind you. So X bar, in my example, that's the 17.4. That's the average right here. And S sub X, that's right there, standard deviation. Mine is 12 people. So put that information in there to your calculator. Like that. And then you need to choose which direction. Mine, it's going to be not equals, because it's whatever you have right there, right? Greater, less, or not equals. You just get it from the H1 right there. Mine's not equals, and then you hit calculate. And I got some numbers. And my numbers are telling me that the T is 2.598. And the P value is 0.024778, but it wants me to round 4 places. So say 0.248. And this other one wanted me to round, it was a 0 here. It wanted me to round 3 places. So there we go. So the T value here, this is T equals 2.598, and it was P value 0.0248, rounded to 4 decimal places, like that right there. All right, so if you're having any trouble getting the P values or T numbers, I'll help you in just a second. Let me finish this problem, and then I'll go back and help you if you're having trouble. So I want to go on to part E. Part E is asking us, it's saying compare the p-value to the alpha level. Well, how are we going to do that? Well, they gave the alpha level up here, right? You can see it right here. They gave the alpha level 0.05. So alpha is 0.05. And what's the p-value? Well, that's right there. That's the 0.0248. So the p-value, 0.0248, how does it compare to the alpha, which is 0.05? Which one, for my example anyway, which of those is bigger, 0.0248 or 0.05?
Oh, 05?
Yeah, everybody see that? The 05 is bigger. So you choose the symbol that goes this way. Remember, it's the alligator open mouth towards the bigger one, right? The 05 is bigger. 5% is bigger than 2%, right?
Mr. Heron, can your T value be negative?
It can. It can be negative. Yes. Yeah, if you have a less than problem, usually is when that happens. Yeah. So the open mouth is towards the 0.05 because that's the bigger one. All right. So then it says, based on this, we should what the null hypothesis? Well, let me help you with that. I wrote out some more steps on that to make that more clear. Let's come on down and take a look here. Okay, so it says, oh, I forgot one thing. It says write weak evidence next to HO and write strong evidence next to H1. We always do that. I forgot to. Let's go back up. This will help you. So I'm going to write over here, weak evidence, strong evidence. That's always the case, no exceptions. It takes only weak evidence to go with HO. It takes strong evidence to go with H1. That's always the case, every hypothesis test you'll ever do. So just write those in, just to be clear, right away. Weak evidence on HO, strong evidence on H1. Let's go back down. So that's in your notes now. I put that in to make that more clear. Weak evidence HO. HO is assumed to be true, like an accused person is assumed innocent. And if the evidence is weak, we will continue assuming the person's innocent. Strong evidence is H1. H1 is the verdict only if evidence is strong. Like an accused is found guilty only when evidence is beyond a reasonable doubt. That's what they're like. Okay, next. Oh yeah, well, we don't need to worry about the p-value right now. Let's come on down to the conclusion here. Here's the conclusions. Here's part E. The p-value is the percentage chance that the HO, which we assume to be true at the start, is really true, and that the results in the study are just due to random luck, right? So when the p-value is very low, lower than the alpha level, there is a very low chance the H0 is really true and the results are just random luck. So we say there is strong evidence to support H1. This is like a criminal case in which strong evidence is shown beyond a reasonable doubt. There's a lot of words here. I might be losing you a little bit. Let me make sure this is clear what's being said here. Catch these words. If when the p-value is low, lower than the alpha, less than the alpha, when the p-value is lower than the alpha, we say we reject the null and say there's strong evidence supporting H1, we reject the null. Does that make sense? When the p-value, is that what we had? Did we have a p-value lower? Was our p-value lower than the alpha? I think so, right? Let's go back. Yeah. See how our p-value was 0.02? That was lower than the alpha, right? So this is a p is low situation. P is less than. P is low. So P is low, which means HO must go away. Remember that statement I gave to help you remember. If the P is low, the null must go. Right? If the P is low, the null must go. If the P is low, the null must go away. So we reject the null in this situation. We're going to reject the null. We're going to say no. So we're going to go back up and we're going to say no, thank you. No, no to the null. We do not believe the null. We made a verdict. The evidence is in. We believe H1, don't we? Let me circle that for us. We believe H1 on this problem. Why? Because the P is low. The null must go away. We rejected the null. We keep H1. The verdict is H1. We reject the null. I should say the verdict, the judgment, the verdict of the jury, H1. Right? We're going with H1. It's the verdict of the jury, H1. Strong evidence in support of H1. That's what we're saying. That's what I'm explaining down here. I'm explaining all this stuff, and I'm saying that the p-value is the chance that HO is really true, and these results were just luck. So when it's really low, there's a very low chance that it's really true and it was just luck. So we say there's strong evidence. This is like a criminal case in which strong evidence is shown beyond a reasonable doubt, low p-value, low chance that it was just lucky coincidental evidence, right? They got DNA, blood samples, and stuff that's just beyond random luck. And so we reject the assumption of innocence. We reject HO. That's what HO always is, the assumption of innocence. And we say there's strong evidence to support H1, a guilty verdict. That's basically what we're doing whenever we reject HO, whenever the P is low. Because P is the percentage chance of luck. That's what P is. That's what a p-value is. It's the chance that it was just lucky information, lucky data. So there's a very low, the P was low on this one. So there's a low chance it was just luck. It's not just luck. The evidence is strong. Reject the innocent assumption, reject HO, believe the evidence. That's what we're doing on this one. So that's what, that means the evidence is strong in this case. We reject the null, right here, we rejected the null. We accepted the H1. We believe what the H1 says, which is what? The average is not really equal to 15. We think there's strong evidence that the consumer advocate group is right and the Meat Man Barbecue people are fudging the truth when they say that the Meat Man Barbecue really takes 15 minutes for the average person to set up. That's really kind of false advertising. Based on our survey of 12 people, the average was not 15, and it wasn't really even, you think, well, could have just been luck, right? Maybe the survey just got lucky, slow people. No, we're saying the chances of that are really low, really low. In fact, what's the chance of that? 2% chance. That's what the p-value is. It's the probability that you just got a lucky sample. It's the chance that, well, maybe you just got 12 people that were just mechanically slow. People like me, I'm mechanically slow, really slow. And they just took them longer to set up the barbecue, but that the barbecue is really right, the average person 15 minutes. No, we're saying, no, there's a low chance of that. We surveyed enough people and the average was far enough off that we're saying there's a very low chance. There's only a 2% chance that it was just a lucky sample. Very low chance. We don't believe it was just a lucky sample. We don't believe that the average is really equal to 15. We're done with that. We believe there's strong evidence that the average is not equal to 15. It's really different than 15, not equal to 15. They're lying, the Meat Man barbecue people. We believe there's strong evidence that they're fudging the truth. Let's see, which of these four does it say? Well, first off, are we going to say not significant? Not significant? Oh, wait a minute. Is it not significantly different from 15? Yeah, that's what we said right here, right? It's not. No, it is. It is different, isn't it? We're saying it's not equal. So it is different. So this is wrong. It is different. They're saying it's not different. This one says not different. No, it is different. Is different. There we go. Statistically significant. That's their word for strong. Significant evidence. Yes. There it is. There is our conclusion to that one.